Today we're talking about cones, and what we're going to do is talk about how to figure out the surface area and volume of a cone. First thing we're going to do is just take a look at the cone itself. It has different parts that need to be labeled. First, we're going to start with the vertex. The vertex is the tip of the cone, just like in a pyramid. There is also a slant height, which you can think about as the height if you were sliding down from the vertex of the cone down to its base. Now there's also, in a cone, a height, which is again straight down from the vertex to the base, and it meets at a 90-degree angle. And then you also have the base radius of a cone. And then finally, the part that's a little different, and it might be kind of tricky to differentiate from the slant height, is the curved surface. And the curved surface is also known as the lateral surface. So these are the different parts of a cone. What we're going to do now is take a look at a couple more cones just to kind of see how the different parts are made and how the surface area is created. So first thing we're going to do is take a look at the cone. And no, wait, what? Why is there? Okay, all right. So there's a Catholic in a cone. Great. All right. So we're going to take this cone. Pretend if you've gone golfing and you're at one of the little stops and there's a water hole essentially, and you've got the little paper cups. This is kind of what we're working with. So I'm going to label the parts of my cup here. Here's the vertex. And I'm creating a perpendicular down to this R. I'm going to label that as the radius. That's my base radius in R centimeters. And my slant height is L, and that's in L centimeters. Now if I were to cut from the vertex to, let's make this point A, if I were to cut there and then lay the paper flat, what would happen is that I get a net that looks something like this over here on the right. Now of course this top part wouldn't be part of the cup at all, because then that would imply that it's covered, but it would help if we're trying to find the total surface area of a cone. So right now we're just going to focus on the top part, the net of the curved, so we're going to look at just the curved surface area of the cone. So then I have V over here, that's my vertex point. I cut over at A, but when I unfold it, I find I have another spot directly at A. That is actually called A prime. What it really just means is that it's the same spot, but you can't label them both as A. So now let's talk about this distance. What do you think that distance represents? And you know what? There's a little hint based on the fact that there's a circle attached to it right underneath. Okay, so the arc, which is from A to A prime, is known as the circumference of the base of the cone. So that means it's 2 pi r, which makes sense because it has to fit around the circle directly below it. And what about the length from V to A? That's L. And this is also L. So really what we did is we took apart the cone and then we ended up with all of this space over here, and that's known as the sector of a circle. So then when we look at the parts together, how to find the surface area of the cone. The surface area of the cone, then we have the curved surface area. Is going to be, let's look at the different values that we have. We have circumference. We have a lateral face. And we have a radius that help to pull apart the cone. So what's going to happen then actually is that the curved surface area of the cone, the formula to find the curved surface area of a cone is actually pi r L. And you might wonder how it's pi r L. But what we'll do in class is maybe take a look at how we can take a cone, cut it apart, and cut each of the little slivers of the cone into little pieces. And then we'll find that we can rearrange them in order to create a rectangle. So the curved surface area is pi r L. Now if we want to talk about the total surface area, of a cone, then we not only need to look at the curved surface area, but also at the circle that accompanies it. And the circle we know has an area of pi r squared. So then the total surface area of a cone is going to be pi r L plus pi r squared. Now what we're going to do is take a quick look at the volume of a cone. We know that the volume of a cylinder is pi r squared times the height. We also know that if we take a pyramid and a cuboid, that the relationship between the volume of a cuboid and the volume of a pyramid of similar base and height is going to be 1/3 the base area times height. That relationship holds true between cones and cylinders. So that what we will see is that the volume of a cone is going to be 1/3 pi r squared h, or 1/3 of the volume of a cylinder with similar radius and height.